Hi everyone. I'm going to start a lecture series on engineering mathematics. So before we begin on to the main topics of engineering mathematics, there are a few important integrals whose proofs are should known to everyone, which you may not be using during your actual engineering mathematics problems, but you will use their results directly. So let us prove the first of such results. It is integral of e to the power ax into sine bx dx. So you have this integral. We wanted to evaluate this. Let it be I. Now it is the first function e to the power ax and sine bx. It's a product, and you see both are functions of x. We should use the product rule. The product rule says if you have two functions of x getting multiplied and you want to integrate their product, then the first function u, so u and v both are functions of x, the first function comes as such: integral of second minus integral of derivative of first into integral of second, and there is this whole integral, right, of this product. This is the product rule, or you call it as integration by parts. Using this rule, we can write the integral I as e to the power ax, first function, as such, into integration of second. Integration of sine bx is minus cos bx upon b. Minus integral of derivative of first, derivative of e power ax is a into e power ax, and integral of v is minus cos bx upon b. So we can see that a little simplification can be done in second integral, but the integral is still there, the integral sign is still there. Let us see what to do with it. We are simplifying the calculations a bit and the signs. So this minus minus is plus. I can write a by b outside. E power ax cos bx dx. Right, now again you have a product, and we can apply the product rule to the second integral now. So first term as such, cos bx upon b plus a upon b. Here if you apply the rule, you will have e to the power ax, first function as such, integration of second, integral of cos bx is sine bx upon b, minus integral of derivative of first, so it is e to the power ax into a, into integral of second, so integration of cosine is sine bx upon b dx. Right, so you see this integral sign has e power ax and sine bx in it, which is the same integrand as you had in I. So we can write I as minus e to the power ax cos bx upon b plus, we open the brackets, a upon b square e power ax sine bx. And here you see this plus and minus is a minus. A upon b into a upon b is a square upon b square, and this integration of e power ax sine bx dx can be written as I. Now clubbing the i's together, we can write 1 plus a square upon b square into I is equal to, here also you can multiply and divide with b, and we can take this term first, the positive term, a e power ax sine bx, and that will be negative b into e to the power ax cos bx. So overall denominator is b square. Here also if you take the LCM, you will get b square as the denominator, and I then can be, after cancelling the same denominator, and we can take e power ax outside common, get a sine bx minus b cos bx upon, so this a square plus b square can be transposed to the other side and we get this result. So this is the result for the integral of e power ax sine bx. We can write a similar result. Let us say I1. This integral is, in place of sine, if you have cosine, e power ax cos bx, then using the same steps and similar calculations, you can find that this integral is going out to be e to the power ax upon a square plus b square. So they are the coefficients of x in exponential function and in the argument of cosine, into a cos bx plus b sine bx. So this integral has a plus here. You can derive and you can see it yourself that for cosine there is a plus here. So these two integrals are very much important. They are very much needed. You don't derive it every time. If you have done it once, I'm sure you can keep this in your mind and you can use it whenever required. So that's it for this lecture.